Hi, Addie. Okay, today we are doing math lesson number 10. Okay, and this is the last lesson before your test. So I'm really excited to give this lesson to you. This is a super fun one. Okay, so the first thing that we're going to do is start out with the 100 subtraction facts. So get that out, make sure you have a pencil, and I'll see you in a minute. Okay, hi Addie. Today we are going to do lesson 10 and we are going to start with the mental math. I hope you did okay on your subtraction facts. I know you're getting better and better at them, so good job. Alrighty, so let's start with mental math. And the first exercise that we do is that we're going to count by 1/4 from, or 1/4. You can say it 1/4 or 1/4 from 1/4 to 10. Okay, so let's try that. And this time it says we just have to count up, so that's good. So let's go ahead and try it. 1/4, 1/2, 3/4, 1. 1 and 1/4, 1 and 1/2, 1 and 3/4, 2. 2 and 1/4, 2 and 1/2, 2 and 3/4, 3. 3 and 1/4, 3 and 1/2, 3 and 3/4, 4. 4 and 1/4, 4 and 1/2, 4 and 3/4, 5. 5 and 1/4. Okay, do you think you can keep going? 5 1/2, 5 and 3/4, 6. You keep going all the way to 10. Pause it if you need to, okay? So I'm going to keep going on to the mental math, the problems that you do in your head. Alrighty, so let's start with A. 43 plus 20 plus 5. Write down your answer. Okay, let's go to B. This is going to be 670 plus 200. You're going to write down your answer. C, 254 plus 20 plus 5. Okay, D, 100 minus 50. E, 300 minus 50. F, 3,600 minus 400. Okay, now we're going to go on to problem solving. So what it says to do is use the digits 5, 6, 7, and 8. So those are the 4 numbers we're going to use to complete this addition problem. And it says there are 2 answers. So what it wants you to do is plug in these numbers, but you only use them once because you see there's 1, 2, 3, 4 blank spaces. So you have to plug these numbers somewhere in these blank spaces and make that problem work. Okay, and you're just going to have to figure out how to do it. So I would kind of take these numbers and put them into groups of 2, like maybe 56, and then add 9 and see what you get. And if it doesn't add up, then that's not the right answer. And maybe try 67, and maybe try 65 or 68. And try all these different numbers and just see if they work. But I want you to come up with the 2 answers, okay? So you're going to have to pause it here and spend some time on this. When you're ready to move on, I'll be here to go over this new concept. Okay. So this is today's new concept. And the new concept goes over sequences. So it's something called sequences. Okay? And a sequence, it says over here on this little sticky note that a sequence is an ordered list of numbers. The numbers are called terms. That's just another word for the number. A term can be 15 or 5 or any of those things. And the ordered sequence has to follow a certain rule. Okay, so let's take a look at some sequences and see if we can figure out exactly what a sequence is. So we're going to start at the top here with sequence number A, or letter A, I should say. And let's just read those numbers out loud and see if you can figure out what the sequence is. And it says 5, 10, 15, 20, 25. So I think that you can figure that out. What are we doing to get from 5 to 10 and 10 to 15? We're basically counting by fives. But what that means is that A is called an addition sequence. And it's called an addition sequence because what you do to get to the next number is you add something. And each time you're adding 5. So that's the certain rule that goes with sequence A. Okay, so let's look at sequence B now. Sequence B is 5, 10, 20, 40, 80, ... And you remember that the ... means that it's going on forever and ever. So the first two numbers of the sequence look like the previous one where you might think that it's an addition sequence, but then it doesn't follow the rule after that. So it must be a different kind of sequence. And it turns out that this is something that we call a multiplication sequence. A multiplication sequence. Because what you're doing, let's say if you're not adding, then what do you do to get from 5 to 10? Well, you can multiply by 2 to get from 5 to 10. Because 5 times 2 is 10. So let's see if it follows the rule. 10 times 2 is going to be 20. Yes, so that follows the rule. What about 20 times 2 is going to be 40. So that follows the rule. What about 40 times 2? 80. Yes. So in that whole sequence, in sequence B, you are multiplying the number by 2 to get the next number. And that's how you can sort of figure out what's next in the sequence. Because sometimes what these problems are is they give you a bunch of numbers like this, maybe like sequence B, and they'll say, well, what's the next number? What's the number that goes here? And the first thing that you have to do is figure out the rule, and then you would just keep following the rule to figure out the next number. So in this case, 80 times 2 would be 160. That would be the next number. Okay, so what you should do whenever they give you an example is what it says right here. Inspect the sequence and then find the rule, and then you just follow the rule to fill in the blank. So let's try one. This is example 1, and it's on page 43, and it says, describe the following sequence as an addition sequence or a multiplication sequence. State the rule and find the next term. Okay, so it wants us to describe the sequence as addition or multiplication. So that's step 1. So it's asking us to do 3 different things. Step 1, is it addition or is it multiplication? Step 2, they want us to state the rule. State rule. And number 3, they want us to find the next number. So remember that when you're following instructions on a problem like this, you have to do all 3 of those if that's what they asked, because that's what the instructions said. So let's look at the sequence. 1, 3, 9, 27. So I can tell right away that it's not going to be an addition sequence, because to get from 1 to 3, you add 2. But then if we add 2 here, that does not equal 9. 3 plus 2 would be 5. So it's not an addition sequence. What if it's a multiplication sequence? What would we have to multiply 1 by to get 3? And then you can see that you can figure out that you would have to multiply it by 3. What about if you're going from 3 to 9? And again, you can see that if you multiply it by 3, you do get 9. And then again, 9 times 3 is 27. So if we follow the instructions, number 1, it wants to know if it's an addition or multiplication sequence. I'm going to say it's a multiplication sequence because I had to multiply by 3 to get the next number. Step 2, state the rule. And it would be multiply by 3. That's the rule because you're doing that each time. And then for number 3, find the next number. Well, to get this number, we would just have to multiply by 3. And then we would have to figure out what is 27 times 3, because those numbers get really big pretty fast. So let's figure this out. 3 times 7 is 21. I'm going to carry the 2. 3 times 2 is 6. Add the 2, and it's going to be 81. So the next answer is 81. Okay, very good. We are going to move on to the next idea. So the numbers 0, 2, 4, 6, and 8, they form a special sequence. So this is a sequence, okay, because it's a list of numbers and they follow a rule. What is the rule? Well, it looks like they're going up by 2. So it's an addition rule and you add 2 every time. And these are obviously called even numbers. And you already know that all these are even numbers when you look at 2, 4, 6, 8. And 0, it includes 0 too, because 0 is an even number. So this is the same as counting by 2s. 0 is an even number. And basically any number with the last digit of 0, 2, 4, 6, or 8 is going to be an even number. So even if that number is huge, like the number might be 5,367,420. Okay, so is that an even or an odd number? Well, because it ends in 0 and 0 is a part of this sequence, that means that this big number is an even number. And anytime you have an even number, that means you can divide something like this equally into 2 parts. So if you had that many dollars and you wanted to share it between 2 people, you would not have to cut $1 in half. It would go evenly into 2 parts. Okay, these numbers 1, 3, 5, 7, 9, you know that these are odd numbers. Okay? And odd numbers cannot be divided into 2 equal groups. So if you have a big number, 5,229,357, because it ends in that 7 and that 7 is a part of this sequence, it's an odd number. And if you had this many dollars and you wanted to split it between 2 friends, well, you'd have to break $1 in half. Or it would be like giving 50 cents to each one by the end of it, but it wouldn't be even. Okay, let's move on to example number 2. Example number 2, and this is on page 45 if you're following along. The instructions say, think of a whole number. Remember that sequence? That sequence looks like this. ... So it goes on forever. Think of a whole number. So it can be any number. And then double that number. Is the answer even or odd? So let's try it. Let's just pick the number 2. If we double it, that means that we're multiplying it by 2. And you get 4. And this answer is even. So let's try it with an odd number and see what happens. 3. 3 times 2 is 6. And again, this is an even number. So that's weird. It doesn't matter if you pick an even number or an odd number, as long as it's a whole number. If you multiply it by 2, then the answer is always going to be even. And that makes sense because remember I told you that an even number can be divided equally into 2 parts. And so if you take a number and you double it, that means that if you had to split it again, you would be able to split it evenly between 2 people because you already doubled it, right? So if it's a whole number and you have to double it, then it's going to end up being an even number every single time. So that's pretty cool. That's kind of fun, isn't it? All right, we're going to move on to talk about scales. And scales, the trick here is to figure out the value of the marks because you're going to get number information or numerical information. It's going to be told to you in the form of a scale in lots of different ways. And this is just one of the ways, looking at a thermometer in the Fahrenheit and Celsius. And so whenever you have like some sort of scale, like maybe it's a gas gauge like that, and you have like little tick marks. And maybe not a gas. What about a speedometer? And you can go from 0 to 100. So the trick is, if they ask you to find the value of something, like what speed are you going, the trick is to figure out, well, what's the value of these little tick marks? Does it go up by 10s? Does it go up by 20s? And once you know that, then you can figure out the whole problem. Okay? So these are two common scales on thermometers, and there's one called the Fahrenheit scale and one is called the Celsius scale. You know what is funny is that we use the Celsius scale at my work all the time. For example, on this side of the thermometer is a C, and that means Celsius. The normal body temperature, so I'm going to put normal body temperature, is 37 degrees Celsius. And that is going to be right there. Okay. And when I measure somebody's temperature at my work, sometimes it's 37, sometimes it's 38, sometimes it's 36, but no matter what it is, I'm always measuring it in Celsius. And it's funny because I don't usually think in terms of Fahrenheit at work. But you can be, because this has an equal number on this side. And it turns out that what that equal number is normal body temperature. So I'll put normal body temp. And it's right there, and it's 98.6. And it's the same. The mercury will rise to the same level right here. So if you had mercury in this thermometer, it would, whoops, that's a wavy line, but that's okay, I'll straighten out. It'll rise to that same number, and you can read it as 37 degrees Celsius on the right, or you can read it as 98.6 on the left. Whoops, I messed that up. 98.6 degrees Fahrenheit. I hope I said that right. 98.6 degrees Fahrenheit on the left is the same as 37 degrees Fahrenheit on the right, and that is normal body temperature. Okay, there's another one that is called boiling temperature of water. Boiling temperature of water. I'll just put H2O. And I don't know if you know this, but water always boils at 100 degrees Celsius. And that's way off the scale. It would actually be way up there. But on this thermometer, it doesn't show it. On the one in your paper, it does show it. So you can look at that. And boiling temperature of water in Fahrenheit is going to be 212 degrees Fahrenheit. And again, that's going to be way up the scale, but they're going to reach the same level. Okay, one more. The last one to discuss is the freezing temperature of water. Okay, so the freezing temperature. And that's going to be way down here off the scale, at 0 degrees Celsius. And water always turns into ice at 0 degrees Celsius. Oh, it's not off the scale. It's not off the scale. I made a mistake there. I didn't see it because I was looking at that 20 and I got confused. But it's not off the scale. It's right there. Freezing temperature of water is right there. 0 degrees. And you'll notice that if you look at it in Fahrenheit, it's 32 degrees Fahrenheit over here. And that is the freezing temperature. So of water. I should say of water, because you have to be specific on that thing. Every other substance has a different freezing temperature. So if you get asked, At what temperature does water turn into ice? You can say 32 degrees Fahrenheit and you would be correct, but you could also say 0 degrees Celsius and you would also be correct. And the interesting thing about that is that if you'll notice, water freezes at 0 degrees Celsius and then it boils at 100 degrees Celsius. So from 0 to 100. And in between, water stays as a liquid. So that's just kind of an interesting fact. I think it's pretty cool. Let's go on to example number 3. And example number 3 says, what temperature is shown on this thermometer? And I took a picture of what you have in the book. So this is exactly the same as what you have in the book. So remember what the trick is. And the trick is to find the value of the tick marks. Okay, and you can see that this thermometer is in Fahrenheit. I'll just say find the value of ticks. And they give you a value of 20 right here and 10 right here and 0. So you need to figure out what does that line mean. So the first part is figure out, well, what do these little tick values mean? So if you go from 0 to 10 here, how many times is it divided? And it looks like it's 1, 2, 3, 4, 5. So there's 5 tick marks in between 0 and 10. So if you figure that out, then you can figure out, well, if I count up by 2s, that would make it work, right? Because if you go 0 degrees here and then jump here and go 2, 4, 6, 8, 10. So you're adding 2 with every tick mark. So you can see why we learned about sequences first before they asked you to do something like this. So every tick mark on this thermometer, but it's going to be different on different thermometers. Every tick mark is equal to 2 degrees Fahrenheit. So then if we want to find the value, let me erase some of this because it's starting to get confusing. So, oh no, I thought I'd erased the picture too. I was like, oh no. Okay, but it didn't, thank goodness. All right, so it wants to know, what is the value of this? So now I know that if I start at 0, I just need to count up by 2s, 2, 4, and this is going to be 4 degrees Fahrenheit, and that's the answer. So the mark is at 4 degrees, so the temperature is at 4 degrees Fahrenheit, and that is the final answer. Okay, that's the end of the lesson, and I will let you go on to your lesson practice. Okay, Addie, we're back, and I hope you really liked that lesson. I tried to make them fun for you. I always do. I'm always thinking about you when I put those together. Now you're going to do the lesson practice, okay? So the lesson practice starts right here on page 45, okay? And you're going to do all of this, and then that's going to be followed by the mixed practice. Okay, so do the mixed practice after that. And there's a lot of it, but remember, you are preparing for a test. So then you have to do all of this page, and there's another little page at the end, okay? All right, so I'm super excited to see what you can do. I hope you enjoyed that lesson. Love you. Miss you, Addie. See you later. Bye.